Good day to you children. In today's lesson, we'll be learning about sum of first n terms of an arithmetic progression. To understand what this means, first let us consider an AP 1, 2, 3, 4, 5. Alright, in our AP there are 5 terms. So now let us add these terms. What is the sum of first 5 terms of this AP? That is 1 plus 2 plus 3 plus 4 plus 5. Therefore, sum is equal to 1 plus 2 plus 3 plus 4 plus 5. This is nothing but 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. So, sum of first 5 terms of our given AP was 15. Now, take another example. 3, 6, 9, 12. So, what is the sum? This AP consists of 4 terms. So, what is the sum of first 4 terms of this AP? It will be sum is equal to 3 plus 6 plus 9 plus 12, which is nothing but 3 plus 6, 9, 9 plus 9, 18, 18 plus 12, 18 plus 12 is 30. So, sum of first 4 terms of this AP was 30. Now, similarly, take another example. 2, 4, 6, 8 and so on up to 200. So, what is the sum of first 20 terms of this arithmetic progression? How are you going to determine the sum of first 20 or first 50 or first 100 terms of this arithmetic progression? To determine the sum of first n terms, the n means it can be anything, alright. So, n means it can be anything or any natural number. So, in this case, if I were to ask you to determine the sum of first 100 terms of this arithmetic progression, then you cannot go on adding them 2 plus 4 plus 6 plus 8. It will be a tedious process. So, we have a formula to determine the sum of first n terms, that is Sn is equal to n by 2 into 2a plus n minus 1 into d. This is the formula to calculate the sum of first n terms of an arithmetic progression, and this can also be written as Sn is equal to n by 2 into a plus al or n by 2 into a plus an. All the three formulas, that is Sn is equal to n by 2 into 2a plus n minus 1 into d, or Sn is equal to n by 2 of a plus l or n by 2 into a plus an. They give the sum of first n terms of our any given arithmetic progression. So, the denotations here are Sn is the sum of n terms, n is number of terms, a is the first term of the arithmetic progression, d is the common difference, l or an is the last term or the term which we are considered about. If say sum of first 20 terms of AP, then the last term of that AP will be 20th term. Otherwise, if say sum of plus first 1000 terms of any arithmetic progression, then the last term will be 1000th term. So L or AN denotes the last term of our arithmetic progression. Without wasting any time, now let's move to the solved examples. The very first question of your solved examples is, find the sum of first 22 terms of the arithmetic progression 8, 3, minus 2 and so on. So here they have given us an AP, that is 8, 3, minus 2 and so on, and they have asked us to calculate the sum of its first 22 terms. So let's write solution. Given A is equal to 8, the very first term of this AP is 8. B is equal to 3 minus 8, that is A2 minus A, which will be equal to minus 5. N is equal to 22. They have told us 22 terms. So N is equal to 22. We have to determine sum of first 22 terms, that is S subscript 22. So Sn is equal to n by 2 into 2a plus n minus 1 into d. So S22, because n is equal to 22, is equal to 22 by 2 into 2 into 8, 8 because A is 8, plus n, once again n is 22 minus 1 into minus 5, because D is minus 5, which is equal to 2 ones are 2 11s are 11 into 2 8s are 16 plus 21 into minus 5, which is nothing but 11 into 16 plus 21 into 5 plus of minus 105. So 11 into minus 89, which is nothing but minus 979. So minus 979 is the sum of first 22 terms of our given arithmetic progression. Let's write it down. Therefore, sum of 22 terms is minus 979. This is our solution. In the second question, if the sum of first 14 terms of AP is 1050 and its first term is 10, find its 20th term. So in this case, they have given us sum of first 14 terms, that is S14. S14 is equal to 1050 and the first term, that is A, is equal to 10, and they have asked us to find the 20th term, that will be A20. To find any term of an arithmetic progression, we need three things. One is A, another is N, and the last one is T. To find A20, we know A, the value of A, which is equal to 10, and then the value of N, which is equal to 20, but we don't know D. We have to find the value of D using the first 14 terms, that is S14, the sum of first 14 terms. Using that information, we have to determine the value of common difference. So solution, given S14 is equal to 1050, A is equal to 10, A20 is equal to what? So and D is equal to how much? So first let's determine D. We know that Sn is equal to n by 2 into 2a plus n minus 1 into D. We know Sn to be S14 and S14 is 1050. When we know the sum of 14 terms, then the value of n will be 14 by 2. 2 into 10 because a is 10 plus 14 minus 1 into d because d is what we have to determine. 2 ones are 2 sevens are 7 ones are 7 ones are 7 fives are 0s are. You can perform the division to verify that. I divided it because both are on the same side. Same side of the equal to sign. Alright. So 150 is equal to 2 into 10, 20 plus 14 minus 1, 13 d. Now transposing 150 minus 20 is equal to 13d. 130 is equal to 13d. 13 ones are 13 tens are. So 10 is equal to common difference d. So the value of common difference for this arithmetic progression is 10. Now we have to find the value of 20th term. Therefore a is equal to 10, d is equal to 10, n is equal to 20, a 20 is equal to how much? We know that an is equal to a plus n minus 1 into d. A 20 is equal to 10 plus 20 minus 1 into 10, which is nothing but 10 plus 190, which is 200. So the value of the 20th term for this AP is 200. In the third question, how many terms of the arithmetic progression 24, 21, 18 and so on must be added to get the sum 78? So in this question, they have given us an arithmetic progression and also the sum, that will be 78. But we don't know how many terms must be added to get that sum. So in this question, our job is to find the value of small n. That will give us number of terms. So given a is equal to 24, d is equal to 21 minus 24, which is nothing but minus 3, and we don't know, but Sn is equal to 78. Now we know that, or using the relationship, Sn is equal to n by 2 into 2a plus n minus 1 into d. Let's put our values. We know that Sn is 78. We don't know n, so keep it as it is. Then 2 into 24 because a is 24 plus n minus 1 into minus 3. Now the 2 which is in the denominator here, if I transfer it to the left side of the equation, it will be multiplied because it is divided here, it is in the denominator. If I transfer it to the left hand side of the equation, then it will be multiplied. We get 78 into 2 n into 2 into 24, that is 48 plus n minus 1 into minus 3. 78 2s are 2 8s are 16, 1 2 7s are 14, 1 15. 156 is equal to, let's open the brackets. This is in the form of a into b plus c. So applying the distributive law. Now you know the distributive law, right? When the expression is of the form a into b plus c, the brackets are opened as a into b plus a into c. Here a is distributed among b as well as among with C, A into B plus A into C. So here in this case it will be n into 48 plus n into n minus 1 into minus 3. So using the distribution law, let's open the brackets. We'll get n into 48 plus n into n minus 1 into minus 3. Moving ahead, 156 is equal to n into 48 is 48n plus n into n minus 1 into minus 3. We cannot transpose anything here because everything contains n. So let's try to solve it. Okay, 48n plus n into n minus 1 is n square minus n. Once again I applied the distributive law here. It is a into b minus c form. It will be a into b, that is n into n minus n into 1. So we get n square minus n into minus 3. Put everything into brackets. So 156 is equal to 48n minus, now multiply 3 to n square minus n. We will get minus 3 into minus into plus minus 3 into n square. We get 3n square minus into minus. It will be plus 3 into n, 3n. So 156 is equal to 48n plus 3n. These are the like terms. So we'll add them. Minus 3n square, 48 plus 3n. It will be plus 51n. Now, in this case, look here. 156 is equal to, I'll remove 3 from this expression. What will be left inside the brackets? Minus n square plus, how much will be remaining if you remove 3? It will be 17n, because if I multiply 3 once again, 3 into minus n square minus 3n square, 3 into 17n, 3 17s are 51 plus 51n will be, we'll get the same expression back. So I'll remove 3 from here now. 3 1s are, 3 5s are, 2s are. So 52 is equal to minus n square plus 17n. Transpose the whole right hand side to the left side of the equation. We will get n square minus 17n plus 52 is equal to 0. We got a quadratic equation in terms of n. So now to find the value of n, we have to solve the quadratic equation. This quadratic equation, solving this quadratic equation is done by the method of factorization, which you learnt in 9th class. Alright, you learned this factorization method in 9th class in polynomials chapter by splitting the middle term. So let's try to do that. N square minus, so first let us write the factors of 52. The factors should be 1 into 52, 2 into 26, it will not come in 3's table, in 4's table, and 4 into 32 are the factors of 52. Now, among these factors, sum of which will be the value of the middle term? 1 plus 52 is 53, which is not equal to 17. 2 plus 26 is 28, which is once again not equal to 17. Whereas 4 plus 13 is equal to 17. So I can write it as n square minus 13 plus 4. I'll split 17 as 13 plus 4 and then write n here plus 52 is equal to 0. So now let us open the brackets. N square minus into plus 13 minus 13n minus into plus minus 4n plus 52 is equal to 0. Now let's group them together. In n square minus 13n. The common term is n. The remaining value will be n minus 13 minus 4, and the remaining value will be n minus 13 is equal to 0. So now in these two terms, what is common? The common term is n minus 13. So the remaining values will be n minus 4 is equal to 0. So now I can write n minus 13 is equal to 0 and n minus 4 is equal to 0. In factorization of polynomials, you used to stop at this step. That is, when you get the factors, you used to end your solution there. But in this case, we are moving a step ahead. We are equating each of the factors to 0 to get the solutions. So n minus 13 is equal to 0. I get n is equal to 13. And similarly, n minus 4 is equal to 0. I get n is equal to 4. So in this case, both the values of n are positive and are natural numbers. So in our given arithmetic progression, that is 24, 21, 18 and so on, both the values of n, that is 13 and 4, will give the sum which will be equal to 78. Therefore, sum of first 4 and 13 terms will be 78. This is our solution. That also means S4 is equal to S13 is equal to 78 for the given arithmetic progression. The fourth question has two sub-questions, and in the fourth question they have asked find the sum of, in the first sub-question, the first 1000 positive integers. That is, the integers are given. We know that integers are the set of negative and positive numbers along with 0. But here they have specified for us to find the sum of first 1000 positive integers. So the positive integers begin from 1, 2, 3 and so on up to 1000. So in this case, A is equal to 1, AN or L is equal to 1000 and D is equal to 1. We don't need D here actually. We will be making use of the second formula, that is Sn is equal to n by 2 into A plus An, because here they have given us the last term. So we don't need D here. N is equal to 1000. So now S1000 is equal to how much? We know that Sn is equal to n by 2 into A plus An, which is nothing but S1000 is equal to 1000 by 2 into 1 plus 1000. 2 1s are 5s are 0 0s are 500, which is equal to 500 into 1001. So after you multiply 1001 into 5, 5005. So 500500, because I multiplied it by 5 here, not 500. So I'll add extra 2 zeros. So our answer is 5,500,000. So the sum of first 1000 positive integers is 5,500,000. In the second sub question, they have asked us to determine the sum of first n positive integers. In the previous question, they had told us to find the sum of first 1000 positive integers, but here they have asked us to determine the sum of first n positive integers. So here the given will be, once again the positive integers start from 1, 2, 3 and so on up to n, some arbitrary number. So here A is equal to 1, An is equal to n, that is our some arbitrary number. So Sn is equal to how much? Now let's put this in our formula. Sn is equal to n by 2 into a plus an. We'll get Sn is equal to n by 2 into 1 plus n. This is a very important result because it gives the sum of first n positive integers or first n positive natural numbers. This is a very important result. Whenever they ask you, this question is asked for at least 1 marks. They'll ask, write the sum of first n positive integers. Then that will be n into n plus 1 divided by 2. 1 plus 1 or n plus 1. Both are one and the same because addition is commutative. So Sn is equal to n by 2 into 1 plus n or n into n plus 1 by 2 is the solution. Fifth question is a little bit tricky one. Alright. Here they have asked to find the sum of first 24 terms whose nth term is 3 plus 2n. They are not given an arithmetic progression here. They have just told you to find the sum of first 24 terms of an arithmetic progression whose nth term is 3 plus 2n. That means an for this AP is of the form 3 plus 2n. We know that an is equal to a plus n minus 1 into d. That is the conventional formula which we use to determine an. But in this case, we'll use a much easier method because this type of question will be asked for 1 mark. Last time your seniors had a little bit of problem while solving this type of question. They had given the value of an to be 3 plus 8n and they had asked to find the value of 10th term. It was asked for 1 mark. So how are you going to determine the value of some 24th term or 100th term when an is of this form? Let's see how we can do that. I'll write when n is equal to 1. N is equal to 1 will be our first term, a1, right? a1 is equal to 3 plus 2, 1, right? 2 into 1 because 2 into n. 2 ones are 2 plus 3 we get 5. Now n is equal to 2. So a2 is equal to 3 plus 2 into 2 which is nothing but 2 2s are 4. 4 plus 3 7. Now n is equal to 3. So a3 is equal to 3 plus 2 into 3. So 2 3s are 6 plus 3 9 and so on up to 24th term. N is equal to 24. A24 is equal to 3 plus 2 into 24. 24 2s are 48 plus 3 51. So our arithmetic progression here a1 is nothing but a, then 7 minus 5 2, 9 minus 7 2. So the value of common difference is 2. This forms an arithmetic progression, that is 5, 7, 9, 11 and so on up to 24th term, that is 51. So this is our AP 5, 7, 9 so on up to 51. So like this you have to determine the value of some nth term whenever an is given to be an is given to you in a different manner like here. So here we have our main objective is to find the sum of first 24 terms, that is S24 is equal to how much? So using Sn is equal to n by 2 into a plus an, we get S24 is equal to 24 by 2 because 24, n is equal to 24 into a is 5. We got the value of a here 5 and an is 51, that is a24 is 51. So 24 ones are 12s are, which is 12 into 56. Therefore, sum of first 24 terms of our given arithmetic progression is 672. Now pause the video and try to find the value of 30th term. Find A30 if an is equal to 5 plus 6n. Alright, find A30 if an is equal to 5 plus 6n. Also, find S10 if an is equal to 2 plus 9n. Pause the video and try to solve these two problems right now. In the sixth question, a manufacturer of TV sets produced 600 sets in third year and 700 sets in seventh year. Assuming the production increases every year by a fixed number, find. There are three sub-questions. So the first sub-question is production in first year. Here they have given us that the number of sets, TV sets produced in the sixth year is, in the third year is 600. Also, the number of TV sets produced in the seventh year is 700, and it increases by a fixed number every year. So every year there is a fixed number which is added to the previous number. So this is an arithmetic progression where given A3 is equal to 600 and A7 is equal to 700, and they have, for the first sub-question, they have asked us to find the production in first year. That will be our A. The value of A is equal to what? So using the general form of AP, since we have the terms here, not the sum but the terms, we will make use of general form of AP, where A3 is equal to A plus 2D, which is equal to 600. This is our equation 1. A7 is equal to A plus 6D, which is equal to 700. This is our equation 2. So now let us subtract them. Subtract these equations. What will we get? First, the signs will be reversed. Plus becomes minus. A minus A is 0. 2D minus 6D minus 4D is equal to 600 minus 700 minus 100. Minus minus cancels. 4 ones are 4, 25 are. So the value of D is 25. Thus, the number of TV sets produced each year increases by 25. And A, we want first, in the first sub question, we want the production in first year. That is our first term A. So to find A, put D is equal to 25 in either of the equation. It can be put in 1 or 2. I'll choose it in equation 1. We'll get A plus 2 into 25 is equal to 600, which implies A plus 50 is equal to 600. This implies A is equal to 550. So in the very first year, the TV sets produced by the manufacturer was 550. Now, in the second sub question, they have asked us to find the production in 10th year. In the second sub, we are supposed to find production in 10th year, that is A10. Production in 10th year, that will be our A10. So to find A10, we need A, which is equal to 550. We need D, which is equal to 25. We need N, which is equal to 10. So A10 is equal to how much? We know that AN is equal to A plus N minus 1 into D. So A10 is equal to 550 plus 10 minus 1 into 25, which is nothing but 550 plus 9 into 25, which is 550 plus 225. 25 nines are 225, which is nothing but 5 plus 2 7, 5 plus 2 7, 775. So in the 10th year, the number of TV sets produced is 775. In the third sub-question, this was the second sub-question. In the third sub-question, they have asked us to find the total number of TV sets produced in 7 years. So whenever the term or the word total comes into play, it means sum. Whenever you see the word total, automatically know that it means the sum. So here we are supposed to find S7, that is the total number of TV sets produced in the first 7 years. Then to find that, we need A is equal to 550. We know the value of A7. They had told us in the 7th year they produced 700 sets. So we'll directly make use of the formula Sn is equal to n by 2 into A plus An. If you feel comfortable enough, then you can also try solving this problem using the formula Sn is equal to n by 2 into 2a plus n minus 1 into d. You will get the same result. Here I am making use of Sn is equal to n by 2 into a plus an, where my A7 is 700. It was given. So and n is equal to 7. So Sn is equal to n by 2 into a plus an. This implies S7 is equal to 7 by 2 into 550 plus 700. This is nothing but 7 by 2 into 550 plus 700, 0, 5, 12, 1, 2, 5, 0, 2 1s are 2 6 are 2 2s are 4, 5 minus 4 carry 1, 10 5s are. So 7 into 625, which is nothing but 4375. So the total number of TV sets produced in the first 7 years by the manufacturer is 4375. That is our solution. In the next class, we will begin with the third exercise of the arithmetic progression. But for your homework, you are supposed to solve the first main of the third exercise, that is find the sum of following APs. They have given you 4 arithmetic progressions and they have also told you the n number of terms. Okay, so you have to find the sum of the following APs. So first main of the third exercise is your homework. Similarly, the second main of the third exercise, where they have given A and An, you have to find you have to directly find the value of n and find Sn here. So second main and the third main is your homework. Keep in mind let me write it for. So your homework is, once again I am repeating it, your homework is questions 1, 2 and 3 from the exercise 1.3. Not 1, 2, 3 means first main, second main and the third main. In the first main there are 4 questions, in the second main there are 3 questions, and in the third main there are 10 questions. Every question is about the sum of first n terms of AP. Read the questions carefully and write them down in your notes below today's notes. Okay, below today's notes. Write this homework below today's notes in your fair book. So I will, in the next class, I will start solving exercise 1.3 from 4th main. That is the 4th question. This is a compulsory work. You have to do it. I am not going to solve it for you. Thank you. Thank you.